Здравствуйте, меня зовут Алексей Черепанов. Я расскажу вам про devkit. Я делал подобный доклад уже про devkit год назад. Теперь, набрав массу, я могу рассказать про больше технических интересных подробностей. Итак, devkit 100 типов хэша спустя. Надо начать с того, как devkit соотносится с John the Ripper. devkit — это кодогенератор для John the Ripper, хотя является до сих пор экспериментом, им пользуюсь только я. John the Ripper — это известнейший взломщик паролей, то есть инструмент для аудита парольной безопасности. Он нацелен на выявление слабых паролей на Unix. Вот. Community Edition, развиваемое сообществом, содержит поддержку более 200 типов хэшей, которые написаны вручную. Также написан компилятор, который умеет выполнять разные типы хэшей по формулам прямо в рантайме. Их бесконечное множество. Вот. При этом это все работает на процессорах, видеокартах и даже на FPGA. Но на FPGA поддержка ограничена только бэккриптом. Проблемы с Джоном, с разработкой Джона есть. Из-за того, что он большой, и надо поддерживать много всего, и надо делать это быстро, сильно растет объем работы. И проблема здесь в том,
which is not a problem because this optimization can be done by one time very easily, but when we have 200 types of hashes, it's pretty difficult to do. It was used as a solution for the problem. It was used as a solution for the bit slice code, which is a standalone topic. The most desired feature is to be able to transfer the code. And the optimization can be considered as the code transformations. When we split our realization into base code and the transformations, the realization can become simpler. And you can apply it to other algorithms. At the same time, we significantly reduce the complexity and the size of the code. To simplify it, we do not work with a sim code. We work with our intermediate representation. We use a very simple instruction language that we use, but it's a high-level object. It's the internal representation, which is applicable for cryptography and cache writing. Typical solutions for hashing are applied here because it's simpler to transfer here. We do not have to restore the construction from the code, but in order to get this intermediate representation, we need to have a language, a description of this algorithm. In devkit there is no compiler. We use a object-oriented DSL language over Python. Let's take a look at code examples. For example, here we connect everything we have in DFT, and we create the code accumulation, and then we say to the DSL where this code should be put into. We describe the variables, and we have the two entries. We combine them, and they put into C variable in Python, but not in the intermediate representation. Then we put the C with the output into intermediate representation as a return from function. After that, we type what we have in the code. And DSL accumulates these instructions in the list. Ultimately, we have C in the beginning, that's the object. All of the DSLs, and in Python we have other DSLs, SymPy for instance. So this DSL code looks like code in a normal language. In SymPy, as a result, we write the instructions to the list. Thus, we can see two entries with a linear result. It's an object. And it's also important to remember that we do not work with Python. We do not affect the bytecode. We can use it in PyPy to make it fast. DSL is the way to fulfill the instructions with lists, which allows us to mix DSL with other code. And use the optimization codes. For the replacement, we don't need to throw away the syntax of the DSL code. We can use the mixed fashion. In terms of the language used, Python is a preprocessor. There is nothing out of Python, nothing of the kind. And Python is a very powerful preprocessor. Allows us to use the C code, adapt it, and use the simple representation. We can also adapt the libraries written in Python. But we have one problem. We don't see the names of the variables from Python. When we have A, B, and C here we just have numbered variables. But let's consider the first and most interesting instruction, addition. We see here that it's just a list of strings, a very exact thing without any abstraction. At the same time, quite naturally, we have a representation which does not change the object. It returns the object with a new name, and it's applied to it even if we work with one single variable in Python. It's a very useful representation. In compilers we have static single assignments, and these representations look very much alike. When we end up having the internal representation, we start transferring it, and that's the key advantage of DFT, where you might want to transfer the code. At the same time, the programmer may come up with a new filter and use many filters for interlink, reversing, and bit slice. There is one interesting final phase, how we put this code in C. We have in plate. We put it in Python. We have a string with a key. We use a standard string template. At the same time, it puts the variables with a dollar sign and puts this file into code, and we have the code generated as the output. The generated code is combined with the intermediate representation and our template, and template is using the macros to connect with it. It identifies how the generated code is embedded. Normally we have C, and we have a test output into OpenCL. There's a problem with that. We're not an ordinary code generator. We output dirty code which matches our internal representation. On the one hand it's bad, on the other hand it's good. We have plenty of code on the one hand, on the other hand we can easily map it into the instruction when we do debugging. And the generated code is using the simple compilation. For John, these formats are using the workflow. Over this year, additionally to 7 formats last year, we added more than 100 formats. And the compilation of formats from formulas. We do it offline, and potentially we need to create a code which is better through optimization. But we do not do this. During this process of development, it turned out that the hardest part was to write that template in C, because it would have to support the features like vectorization, bit slicing, interleaving. On the other hand, we were forced to create new templates because we had TrueCrypt hash, for example. For TrueCrypt breach, we use IS decryption of data. After that we see some magic true, and we check and verify CRC. We did not put CRC into the algorithm. It stayed inside the template. So if we multiply the templates, we multiply the work. And we just need to put these parts inside devkit. Last year we proved that we can describe the algorithms, make the algorithms effective. This year we saw that we can create many algorithms easily, but so far we cannot use many algorithms and apply optimization. Devkit was for fine-tuning of the optimization. And it proves a problem, because when we need to generate a lot, we need to develop a strategy for optimization and automate it, automate this process. Use tests for automation, which will follow. Another problem here is that devkit backend optimization internal representations are developing with cache. And with the hash development, we can create a new instruction, add it to all of the optimizations, add a new optimization, and make something in backend. And devkit is actively developing, and it seems like I'm the only developer who can develop it and use it. So what are the conclusions? John devkit can create a good code. It can create lots of caches, but it cannot do many of the good ones. Thank you very much, and we'll be working on it. And the code will be in the repository. Do you have questions?
Ну, у меня такой очевидный вопрос. Были ли проведены...
Did you have benchmarks? Were you able to get such accelerations? And last year we had it. And the best performance was 10% increase through the optimizations that we did not have in John. This year we did not tackle the speed that much, and we are lagging behind many times by the size of the vector, because we do not vector the code. But it will be there. Did you check the Russian realizations of hash for this utility? Because they are published on different websites, and the different conferences mentioned some achievements. What about your solutions? Well, in Russia we use Ghost with a Strybeck code name, and the hashes there are very interesting. They are very friendly to bit slicing, and they're not too friendly for other optimizations. We'll be working on that. So you have not tried that yet? No, not yet. Thank you.
Давайте поблагодарим Алексея за доклад.
Thank you, Alexei.